Now let's deal with the second type of instructions in C language, arithmetic instructions. Now we have seen the declaration instruction. A variable is declared with some data type. If a variable had to be operated with some value, if a variable need to be associated with some value, I have to write some instructions. The instruction which we use for saying an arithmetic operation is nothing but arithmetic instruction. The name itself says what exactly is an instruction, arithmetic instruction. Now, let's write a simple mathematical instruction and try to convert this into C language. Whatever the variables which I am going to use in this entire session of this arithmetic instruction, presume that they are being defined or declared with some data type. Suppose if I write an instruction as x equals to a by b. Now in mathematics we have been regularly using this particular by to indicate division operation, but you can't use this in C language. The equivalent of this particular C language instruction is x equals to a slash b. Now slash is an operator which is used to get the quotient after dividing a and b. Now a C language instruction will always end up with a semicolon, hence I'll place a semicolon at the end of this. If you identify that I have written variable on the left hand side also, I have a variable by name a and b on the right hand side also, assuming that a, b and x have been declared of some type. Now in this, x will store the result which is defined or produced by a slash b. Always an arithmetic instruction should have a variable on the left hand side. Whatever the result which is produced by an instruction in the right hand side, that result should go on some variable in the left hand side. If you don't put any variable on the left hand side, the result which is produced by the arithmetic instruction will be ignored. Hence, always associate some variable on the left hand side. Let's write some mathematical expressions and try to convert arithmetic instructions in C language. Suppose if I say z equals to b square minus 4ac. Now we know that in C language we don't have any representation called as x raised to y. If it is a simple square term or a cube term, preferably use arithmetic multiplication operator to do this. I'll say b asterisk b minus 4 asterisk a asterisk c and a semicolon. Now here you'll be able to find that b square has been written as b asterisk b, 4ac has been written as 4 asterisk a asterisk c. So here asterisk indicates there is a multiplication operation. Suppose if I have an instruction as say p equals to q divided by r plus say n. Now when I say q divided by r plus n, this mathematical operation should be written as p equals to q slash r plus n. Now wait at this place. You can't just make a translation. If I write something of this sort, it means that here there is a translation of instruction p equals to q divided by r plus n to its equivalent C language. But it will not work as per our mathematics. So why? Question yourself why, and then you'll have the answer. So here, when I solve this mathematical expression, the denominator is r plus n, which will be done first, and then that will be divided by the numerator. But if I translate this into C language, by converted to slash plus placed as it is. In this case, q slash r is done first. The result will be added with n, because priority of slash is much more than this particular n. Hence, we should not just translate, we should construct instructions. So I had to increase the priority of plus before this particular slash. Hence, what I'll do is I'll use round brackets. Suppose if I'm say that x equals to square root of a plus b. Now we know that we can't use the square root symbol in C language. For that reason, what I'll do is I'll say x equals to sqrt of a plus b. Now sqrt is a predefined mathematical instruction which is used for finding the square root of a number. Now if I use this, then I'm supposed to include a header file called as math.h, because your square root function is defined in that particular function. If I write an instruction as y equals to m raised to n, even this instruction is not possible in C language, because we have discussed and we have stated that x raised to y representation is not possible. So How to write this instruction? Y equals to, so this POW, pow, bracket M comma N and a semicolon. Now POW is again a standard library function which says M comma N, where M is base and N is power. When I include SQRT and POW, you're supposed to always include a header file called as math.h, right? So a division operation, a multiplication operation, a square root operation and an x to y operation. What if I have an instruction which is using multiple brackets? Mathematically, I can write instruction as 2 square brackets, 3a, say curly brackets, 4b plus c round brackets, 2 plus a, round brackets complete, curly brackets complete, square brackets complete. Now, if I have to translate this instruction, in your mathematics, you can use any type of brackets to represent arithmetic instructions. But in C language, we have to use only round brackets to say this expression. Now, how do I do this? Check this. 2 multiplied by, so a square bracket will now be replaced by round brackets. 3 asterisk a. Now, without any sign, it is noted as multiplication, but here I am supposed to do it explicitly. Again a round bracket. 4 asterisk b plus c asterisk. Again bracket. 2 plus a, round bracket complete. One round bracket for this and one more round bracket for this, and to end this instruction I'll say semicolon. So here we have used arithmetic instructions with only round brackets. Now if I had to analyze these instructions, in all these instructions you'll find that you'll have a variable on the left hand side. Suppose what if I write a plus b and semicolon? Is it a valid instruction in C language? Yes. Syntactically this is very much valid, but the result which is produced by this instruction will be ignored. It will not be stored at some place. So whenever I use an arithmetic instruction, make sure that the result is collected at some place. If not, the result will be produced, but it will be ignored. Suppose if I had to increase the priority of the operators, 1 plus 1 divided by 1 plus 1 divided by 1 plus I. Now, don't translate this instruction again. Try a logical based instruction. How to do this? 1 plus 1 slash, again 1 plus. Now here, you want to do this particular plus before this particular slash happens, since use a round brackets. Again put 1 slash. If you come across an operator which is having a lower priority than this slash, then you can use brackets. Again I'll have 1 plus. Now here, again plus has to be done before slash, so again use a round bracket. Plus I, round bracket completes, and one more round bracket complete and a semicolon. If you say P equals to, here you have to say P equals to. So all these instructions which I have described are going to perform one or the other arithmetic operation. We call these as arithmetic instructions. And in our simple C programs, we'll be using these arithmetic instructions. Thank you.